All right, so back to organic chemistry synthesis, right? Remember that a big goal of organic chemistry was to study live systems. And so a big thing with live system is being able to artificially make your amino acids. So let's take a look how we're going to do this. Again, what we're talking about here is the synthesis in like a lab environment. So artificial / lab made. So this is not how amino acids are transformed in living organisms. They have a much more complex and a much more efficient way to do it. All right, so we're going to start off with one of the reactions that we already know, the Hell-Volhard-Zielinski reaction, which wasn't too important of a reaction when we learned it back in the day, but now it is. So what we have here is a carboxylic acid, and then we're going to do what the Hell-Volhard-Zielinski does is it brominates in that alpha position, right? So alpha bromination. So what we do is we add some PBr3 and some Br2 in the first step, and then in the second step we add some sodium hydroxide. What that does is inserts this Br group. And then after that, we can then do another reaction. What we do is we just add some excess ammonia. And that'll perform an SN2 reaction on that bromine. And replace it. And boom, we've got our amino acid, right? There's the acid, there's the amine, there's the R group. We've got our amino acid. If you think about this reaction, maybe some issues that you might come up with is that this amine might do polyalkylation. Remember, we learned that alkylating amines generally isn't a good idea. In this case, it's okay because this group is so bulky that we don't have to worry about polyalkylation. In this case, note that I don't have any wedges or dashes. We get both enantiomers. So that's one of the cool thing about proteins and enzymes is that they can very selectively make products. They don't make both enantiomers, they just make the one that they want. In our synthetic lab situation, with this reaction, we get both enantiomers. And then you'd have to separate the two or something like that. So let's just take a look at overall this reaction, what we have, and then kind of what we add. So think about your amino acids. Right, we've got a carboxylic acid, we've got an amine, and we've got an R group. So if you look at our starting material, we've already got our carboxylic acid and our R group. What we're adding is the amine. And then we'll see other reactions where, we have the amine and then add the other components.